Core 3, Summer 2012, Question 8, it's a trig identity. Always remember you've got to work left to right. And in this case, we're going to be using the identities which are generated from cos squared plus sine squared equals 1. If I divide everything by cos, I get 1 plus tan squared equals sec squared. And if I divided the original equation by sine, I would have got that cot squared plus 1 equals cosec squared. So starting with the left-hand side, I have cosec squared x minus 1, which is cot squared x upon sec squared x minus 1, which is tan squared x. And cot squared is 1 over tan squared. Alternately, I could have made tan squared 1 over cot. Tans are going to cancel, that leaves me with 1, which is the right-hand side, and I've answered the question. Part B, we're solving a trig equation. We can't solve for sec, but we're going to use the fact that sec is 1 over cos. So 1 over the cosine of 2x minus pi over 4 is minus 2. That means that the cosec of 2x minus pi over 4 is minus 1/2. Get a calculator, answer. 2x minus pi over 4 is 2 pi over 3. If I draw a cast diagram and mark that on, and I mark on my second equation, I need to look at my limits. I'm going from 0 to 2 pi or 0 to 360. So those first two angles are 2 pi over 3 and 4 pi over 3. Because of the 2x, we need to go around twice, which means I'm going to add 2 pi to each of these, which is going to give me 8 pi over 3 and 10 pi over 3. Now I need to solve the equation, so I'm going to add pi over 4. So 2x could be 11 pi over 12, 19 pi over 12, 35 pi over 12, and 43 pi over 12. To complete my answer, I'm now going to divide everything by 2, which will give me 11 pi over 24, 19 pi over 24, 35 pi over 24, and 43 pi over 24. If you don't like working in radians, you can work in degrees, but please remember at the end to convert your answer back into radians using the DRG button on your calculator.